We say that a team is better than the sum of its parts, but in terms of mass, they're equal, right? Well, that might be true for most things, but for atoms you can't say that. It's actually less. So here's why. It's the 1890s and this dude, Henri Becquerel, discovers that uranium salts emit rays that can be detected by a photographic plate. And this discovery leads to what we know today as radioactivity. But why do nuclei fuse together or break apart in the first place? And why is energy produced when they do so? Well, it's because of a little something called binding energy. If you weigh the total masses of individual protons and neutrons against themselves in a nucleus, you'll find that they weigh more. So when atoms are made, where does this additional mass go to? Well, it's converted into energy. Like how Einstein linked mass to energy, the extra mass that we saw was lost becomes a sort of energy glue that holds these protons together, which is binding energy. It's there because the nucleus is packed with positively charged protons, and if there was nothing to hold them together, their similar charges would repel each other and blow up our atom. When atoms are made, we take our protons and neutrons, cut off a tiny piece, stick them together, and convert these removed pieces into a form of energy glue that acts like a rubber band and holds them together. This is where the additional weight went and why it's called binding energy. Think about it as squeezing a little bit of mass out of these limes and using it to glue them together. And this is a really big deal. Take nuclear power plants. The energy released when we break a uranium atom's nucleus into smaller nuclei, or the energy released when hydrogen in the sun combines into helium, is the extra binding energy that got kicked out during the reaction. The radioactivity I mentioned earlier is this energy. So simply, the binding energy is the energy locked in the nuclei of an atom that keeps the nucleons trapped in this dense way. Essentially, binding energy binds the nucleus together. It has crazy potential, but if used strongly, things can get very, very deadly.